Welcome everyone. Today my team and I are presenting our Capstone project sponsored by CGI Federal. Our main challenge was addressing the growing need for proactive application security. So instead of treating security as an afterthought, our goal was to build an end-to-end, fully containerized DevSecOps solution that shifts security left. And as you'll see in our video, we achieve this by automating security scans using open source tools within our pipeline and managing our infrastructure entirely as code. Our entire architecture was designed to align strictly with the CISA Zero Trust Maturity Model and NIST Secure Software Development Framework. So let's dive right in.
Hi, my name is Eric. Our containerized DevSecOps solution starts with executing a master playbook, which will launch all the tools a developer may need to achieve a secure design lifecycle. Note, we are implementing Zero Trust via Ansible's Vault, which encrypts all environment keys and ensures they can never be viewed in plain text. The deploy YAML playbook will grab files from our Git runner. In this setup, a Git repository contains all the Docker Compose files necessary to facilitate pen testing and SBOM generation needs. Inside the Docker Compose files, keys are not written directly. They are digesting the encrypted environment files as they are being deployed. If we look in the master playbook, we can see each service folder we are requesting: Harbor, OWASP, SonarQube, Grafana, and Defect Dojo. This playbook is very robust in that it can queue and build up the containers with any needed reconfigurations or parameters and checks to ensure there are no port conflicts for databases and host addresses. We also prune and remove unused, untagged Docker images. All this to say, the pipeline deploys very cleanly. For large volumes of containers, flushing resources in Docker can sometimes take a while. After all our containers are deployed, we can open up a service in our local host. In Defect Dojo, we can see our production app running, and it is already failing several security tests.
So for this demonstration, we're running our entire DevSecOps environment locally, and we're using a Docker Compose setup to orchestrate all of our services. And we're starting in the Gitty, the code repository, but we're going to take a quick look at the Harbor to see the latest image tag is version 53. So to trigger the pipeline, we're going to make a quick commit directly to our Gitty Actions workflow file. So once committed, our pipeline instantly takes off with the build scan push job. And here the runner checks out our repository and initiates a static application security testing or SAS scan using our SonarQube service. And then it builds the Docker image that we have locally in the repository and generates a software bill of materials using Trivy to check for vulnerabilities. And then it'll finally push the newly built image to Harbor. So then with the image successfully built and scanned, the deploy job takes over. So as you can see in our local logs, as soon as this finishes, the environment is pulling a fresh image from the Harbor and then deploying the application to our environment, handling all the network and service initialization in real time. So here are the logs for the terminal. We're just going to docker ps grep our production app, and you can see that it's up and running, and that's the service that was just deployed. So the next, now that the application is live, our DAS scan job executes, and we're running an OWASP ZAP baseline scan to perform dynamic application security testing against the running container. And once it's finished, it uploads the ZAP artifacts directly to Defect Dojo. And if we check back in Harbor, you can see our image tag, the new one is version 54, has been successfully pushed. So now let's review our automated reporting. In SonarQube, our code successfully passed the quality gate, confirming 0 new vulnerabilities or security hotspots in our static code. So moving over to OWASP DT dependency tracker, we can analyze the SBOM generated during the build, and this dashboard maps all of our application's components against known vulnerabilities, providing us with an inherited risk score and flagging specific CVEs that require our attention. So for centralized vulnerability management, we use Defect Dojo. And here you can see the active findings imported directly from our ZAP dynamic scan. And this just gives us a clear actionable list of remediations and mitigations, like fixing missing content, security policy headers, etc. So I'm just going to click into just a random one of these, and it'll show us just a couple of the remediations or just information about it, what we can do, all that kind of stuff. So finally, we maintain complete visibility over our environment using our observability stack. With Prometheus, Promptail, and Loki feeding into our Grafana dashboards, we can monitor the real-time health of our containers, tracking CPU usage, memory consumption, and network traffic across the entire pipeline and our containers in our environment. Our second dashboard uses Loki and Prompto for log visibility, and the log volume panel tracks spikes and errors, ensuring the searchable audit trail required for secure software development framework compliance. And that's the end of our video. So we'd like to thank CGI Federal for their technical guidance and support throughout our whole Capstone project. And thank you for watching.